Hello, chemistry folks. We're here to talk about pH and its long lost forgotten counterpart, pOH. I like to think about pH as the power of the H's, and I like to think about pOH as the power of the OH's. Those are the two components that go into making up acids and bases. I also like to think about acids as a Miss Pac-Man who's running around the place as a positively charged hydrogen ion or hydronium ion, reacting with everything that might be oppositely charged from it. Now for bases, I think about those as Pac-Man. He's a negatively charged hydroxide ion running around the place gobbling up positive charged things. So let's consider a beaker full of water. If I were to take hydrochloric acid and dump that in there, it would ionize into the hydrogen ion and chlorine ion, and I would be left with a bunch of those positively charged hydrogen ions floating around the solution. It would be acidic. Now for the opposite situation, if I had a beaker full of water and I took sodium hydroxide and dumped it in there, it would dissociate into the sodium ion and the hydroxide ion. I can see all those negatives as the hydroxide. This would be a base. Now let's consider that acidic solution. It's common that someone may want to know what is the pH of that solution. To figure that out, I take the negative log of the concentration of H's, the molarity of it, and that will give me my pH. Now in doing this, I have to know what that molarity is. In this case, we're going to say the molarity of that acidic solution that was added was 0.03 molar. I plug it into my formula, and I figure out the pH. Now let's consider the basic solution. Let's go ahead and say I have my beaker full of water and I dump in 0.004 molar NaOH. As I do that, you're going to see it dissociates and you've got a whole bunch of negative hydroxide ions floating around in there. I want to know its pH. So I write down the formula, negative log of the concentration of H's equals the pH and, oh shoot, I don't know the H's. I know my OH's. That's what NaOH makes. It doesn't make H's, it makes OH's. So what I've got to do is I've got to flip this formula around. It's actually negative log of the concentration of OH's, but this will now give me my pOH. I plug the numbers into my formula, and I get an answer for my pOH. Now come back to the problem. I still need to know what is the pH. Thankfully, there's this handy little formula that says, within a solution, the pH plus the pOH will always equal a value of 14. So I plug my 2.40 pOH into the formula and I find out that my pH is 11.60. But that leads another question. How can there be any power of H's? This is an OH type solution. This is a base. Well, let's go back and look at that solution. If I look at one of those waters, what will be happening no matter what we do is some of those water molecules will be ionizing. And when they ionize, they'll turn into an H plus and an OH minus. So yeah, even though this is a basic solution, there's still going to be some hydrogen ions floating around in there. Now there's one more formula we can add to the mix. Let's say you know the pOH and you want to know the molarity. Well, in this case, I'd take 10 raised to the negative pOH, and that will give me my concentration of OH's. So if I go in reverse in this problem, 10 to the negative 2.40 will give me 0.004 molar, just like we started with. So let's go back to our acidic solution and apply all these formulas the same. The pH plus the pOH will give us 14. So if I know that my pH is 1.52, I can plug that into the formula and find out that my pOH for this solution will be 12.48. Again, you don't think about there being any power of OHs in a type of solution like this, but if we look at one of those water molecules within the solution, some of them will be ionizing, and when it ionizes it will turn into an H+, which there's already tons of those, and an OH-. And to close, we can also take the pH of a solution and turn it back into molarity. We just need to do 10 raised to the negative pH, which will give us our concentration of H's. So when I do that, I do 10 raised to the negative 1.52, and end up getting a molarity of 0.03 molar HCl, just like we had started off with in the beginning.